For our very first official proof, we're going to start off with an algebra proof. And this proof, notice that we've got our table already kind of set up for our two columns. We've got our statements and reasons already up there. We are going to start with number 1, which we're always going to start for our very first statement with what you're given. So the very first thing I'm going to write down is that 2 times the quantity of 3x plus 1 will equal our 5x plus 14. And do you remember what our reason is?
Given.
That's what's given.
Now, question. Are they always going to give you, I'm just noticing, because the ones we did yesterday, which weren't really the official formal proof, are they always going to give you what's listed up top, given, and they're going to give you something and then prove?
They will. So you're going to know that your answers are right. It's not a matter of that. It's coming up with that logical argument.
Okay.
And so that's what we want to do, is we want to be able to justify why what we're doing, why we can do that mathematically.
Can I just substitute 12 into the original equation and do it that way?
Well, that would be nice, but that's what we're trying to prove, that it does equal 12.
Okay, I gotcha.
So we want to show our work to get to that answer of x equals 12, but once we're there, then we're going to be all done and we won't have to do any more. All right, so what would be your very first statement that you would make?
Well, I think the first step that I would take is I would just distribute the 2. So have 6x plus 2 is equal to 5x. And then my reason, and I have to number that reason, I'm gonna say distribute, so D-I-S-T.
Perfect. Okay. And note, I love that you said you were going to have to number it, because whatever you number your statement as, you have to number your reason with that exact same number that goes with it.
Okay.
All right. Let's go ahead and move to our next statement. Now that we've gotten this far, what would you do next?
I'm going to subtract 5x on each side.
Okay. So what are we going to be left with?
I'm going to have x plus 2 is equal to 14.
Okay. Awesome. And then that reason would be?
SPO, so subtraction property of equality.
Because we subtracted the exact same thing from both sides. Wonderful. Now, step 4, to get that x all the way by itself?
I'm going to subtract 2 on each side, so I get x equals 12, which is good because of where we're going. And my reason for that would be SPO again.
Wonderful. Now, notice that those last 2 steps both used SPO. So, because they have the same reason, could I have put those 2 steps together? What do you think?
Well, I remember kind of when we were talking yesterday about kind of that, how we wanted each step separate, but the fact that they have the same reason, and really they don't really depend on each other. Like I could have subtracted 5x and subtracted 2 in the same step because they have the same reason. So I think we could do that. Now, I personally, unless I like to keep, steps kind of in order, of course, but I try not to do too many things at once, especially with the geometric proofs when we get new to that.
Right.
Algebraic proof, we're comfortable with this, so this should be fairly easy for us.
Exactly. And I just know some of you are probably asking yourself that same question. And yes, when it's a basic algebra proof like this, I'd be okay with putting those 2 steps together. As long as it's the same reason. Now, if one was an SPO, one was an APO,
nope.
Can't do that. They have to be the exact same reason and not depend on each other. I love how you said that too.
Now, we are actually going to do our very first official geometric proof. And notice we already have the 2 columns set up for you. All right. Now, one thing to keep in mind with the 2-column proof, we have this already set up. When you do this on your own, you want to do that. I always tend to make more space on the statements side than the reasons, just because there's usually more work on that side. Don't have to. You always start. I always just, once I get my 2 columns, I typically just jump right in and I write down the given and then the reason next to it. Now, one thing to notice about what's provided is they're giving you 2 different things.
Oh.
Okay?
Okay.
And it's not an algebraic equation. These 2 things are more geometric. That's why it's a geometric proof. Now, you're going to see this different ways. Sometimes you'll see in the book, they'll separate the given out. They'll write this first part, B is the midpoint of segment AC, in one step, and then BC equals QR in another step when they use it. I personally, and I know Mrs. Hoke-Raby does this too, I like to write all the given in one step so that way I don't forget about it.
Exactly.
So I'm going to go ahead, if you're cool about it, I'm going to go ahead and write it down, B is the midpoint. And you'll notice I'm going to start abbreviating some things just because we can, for one. And two, it allows us less writing, and it still is clear and everything. Just be careful of how much you abbreviate because you want us to be able to still know what you're talking about.
Right.
And what's the reason for my very first step?
Given.
Because that's what was given to us. Now, when you're dealing with a geometric proof, it's a little bit different because you're going to have to use some like definitions, postulates, properties that we've dealing with. What I tend to do is I always tend to kind of look always also at the proof, kind of where we're going, kind of get an idea of where we're going. Notice they're trying to have you prove that this segment measure is the same as this segment measure.
Okay.
The other thing that I like to do is I look at the given obviously first, and I ask myself, is there anything from that given that I can say more?
Okay.
So what I mean by that, and let me read the first part of given. It says B is the midpoint of segment AC.
So right there, could I mark in the picture that if I know it's the midpoint, then I know that AB and AC should be the same measures because the midpoint tells me that it splits it into two congruent segments.
Okay, so how would I write that?
Okay, I'd write that AB is congruent. Yeah, segment AB is congruent to segment BC.
Now, what supports that? How come we know segment AB, and I'm going to go ahead and label the picture, is congruent to segment BC?
Well, I know that because isn't that the definition of a midpoint?
Yeah, if you look up the definition, it specifically says a midpoint divides a segment into two congruent parts.
Okay.
So why not? Now, I, again, abbreviate. I use DEF for definition of a midpoint. Notice I abbreviate midpoint from the last statement there.
Okay.
Okay? So
I can use those definitions as my reasons. That's right. We talked about that. I forgot.
Yeah.
Okay.
Yeah, and here's the deal. We basically took care of that first part of the given. So once you've taken care of that, you've already used it. You're not really going to probably use it again, okay? Not necessarily. So then what I'm going to do is I'm going to kind of look at the next part of the given. It says BC is equal to QR.
Okay.
All right, so here's the issue. And I don't know if you see this or if you're even questioning it, but it's something that's new. Notice what I have here written and what I have here written are both...
They're similar, but yeah.
Yeah, but they're not the same.
One's an equal sign, one's a congruent symbol.
Okay.
Does that matter?
It does actually matter.
Okay.
We need it when you see congruence and equals in a problem, we need to have them all the same.
Okay.
Right? So, and one way I know where I'm going to go is where I'm ending. I'm dealing with equality in the end. So, is there a way to take my congruent statement and make it into an equality statement?
Well, sure. We know if two segments are congruent, then their measures are equal. So, could I just say that the measure of segment AB is equal to the measure of segment BC?
And the way to do that is just take off the segment bars. Instead of congruence, you have an equality symbol.
Okay.
And what allows us to do that?
Well, that's what it means to be congruent. Is that a definition of congruent?
It is a definition. Notice our two reasons so far are both definitions. And notice I'm using some symbols, abbreviations. Definitely get comfortable with that.
Okay.
All right. And again, the reason why we're doing this is because of the fact that we see congruence and equality in our proof. We want to make sure they're all the same. So let me go again, backtrack here. I basically have dealt with that.
Now, I needed, though, to first state that they were congruent, right?
Uh-huh.
Because that is the definition. The definition of midpoint is not that the two segments are equal, it's that they are congruent.
I love that you brought that up, Mrs. Hoagravy. I almost called you Mrs. Palermo again. I'm thinking of myself, I guess. Sorry about that, hon. All right, so definition of midpoint, if you look it up in the book, it says congruent. So we kind of have to be picky about it. And I know some of you are like, well, congruence means equality. Well, yeah, but that's another definition.
And that's how we've talked about that the notation is really important. Mm-hmm. This is one of those times that notation is really important.
So we've dealt with, we knew, let me backtrack. We knew B is the midpoint of AC, which allowed us to say AB is congruent to segment BC. So if we knew that, we know that. So check that off, right? Once we knew this, we can say equality. So we've dealt with these two things, but we still... I'm going to go back here. We still haven't really used this.
Okay.
And when they give you something in a proof,
there's probably
99% of reason you're going to use it.
Okay.
And I'm going to start this because we still have to use this.
Okay.
Right? So what are you noticing?
Ooh, they both have that equal to BC.
So is there a way to write something new from these two statements?
Yeah, that's that transitive property, right?
So what would I
could
say?
say that AB equals QR. Hey, and that's what I was trying to prove too.
And you want to keep that in the back of your mind.
Okay.
All right. Sometimes, I mean, in the beginning, it's going to be hard to remember that, but go back there. And Miss Hograby already said she could use a transitive property. Now, this is one, because transitive property works for equality, of course, and we're doing here. There's actually another property that you could technically use. And if you're questioning it, I'm bringing that up because what you can also do is you could replace in this equation in for BC what?
QR.
So if I just substitute in there, so you could technically use substitution and that would also work.
Okay, good to know.
So how do you know when you finish your proof?
When I end with what I'm supposed to prove.
And notice, and this is your first geometric proof, notice it's not super long. It's not super complicated. We use some definitions, some properties. We're going to add to the list of reasonings. And honestly, guys, when we add more reasons, the proofs actually get easier because you have more ways to go about it and you're going to be more comfortable with it as well.
Okay, our next proof, notice that we are given that segment AB is equal to segment CD, and we're given that segment AC,
We're not given it, are we?
no, sorry, we're proving that segment AC is equal to segment BC. This is where we're trying to get, was that these two are equal. Right now, what we know is that AB is the same measure as CD, and I'm just going to mark them with tick marks. I like to, anytime I've got something that I'm given, try to mark it on your picture. And notice that what I'm starting with is an equality statement and what I'm ending with is an equality statement.
Well, that's kind of good.
That's nice. So hopefully we won't have to do a whole lot of going back and forth between congruence and equality on this one. We always want to start our proof with what we're given. So AB, the measure of segment AB, is equal to the measure of segment CD. And that I almost put it to. I did put it to. That reason for step one is
Given. I do that all the time, Mrs. Hograby. Well, it's logical one.
You want to do a one, then a two. All right, now, here's the thing. What we're given that these two are equal to each other, the only statement that I could really make after that is that, well, then that means that they're also congruent, but we said we don't want to have to jump and forth between equality and congruence. So what we really want to do is to try to figure out how do I get from knowing that these two are the same to talking about all of AC and all of BD being the same.
So so what you're saying, and kind of feeding off from the last one we went through, if the given doesn't really say much after, besides this one saying we can say they're congruent, but that's probably not necessary unless we find out we have to. We can always throw it in there.
Right.
But what you're saying is that we need to say something about AC and BD because of the fact that we're trying to prove something about them.
Right.
Okay, so where should I look to determine that?
Good question. Well, we've talked about some other properties and some, we've talked about some postulates and some theorems before, and there was actually a postulate that we talked about, the segment addition postulate. This is going back a little bit, that we talked about, that we said if we have two segments that are right next to each other, they share that common endpoint, that the sum of these two segments should equal that third segment. That was that segment addition postulate.
And you can tell that because from the picture, it shows that AB and BC that form that whole AC, so that we can say from the picture, right?
Right. And again, it was kind of one of those no-brainers. That's why it's a postulate.
Okay.
And in order to be able to talk about all of segment AC, I somehow have to establish it. So to establish it, we're going to use that segment addition postulate to do so.
So I would put AB plus the measure of BC is equal to the measure of AC, and my reason would be segment addition postulate. Now, I like to use SAP or SAP. Do you?
I do too.
Okay.
And we introduced that acronym when we first did this, but just to make sure you guys remember that, SAP, we're going to use for segment addition
And
postulate.
guys, honestly, we prefer you use an acronym as long as you know what it means.
And we know what it means.
So don't don't make up an acronym on your own and we're not sure. And don't use SAB if you're like, I don't even know what that is.
Right.
Make sure you're clear. If you have to write it out in words, then do that. Eventually you'll get the hang of it.
Yep. All right, now, we've established AC, but we haven't established BD yet.
Okay,
So what do you know?
Well, I'm going to put, in my next step, I would go ahead and put the fact that BD is made up of BC plus CD is equal to BD. And that reason is SAP as well, right?
Right.
Now, when I look at this, I'm noticing that steps 2 and 3 have the same reason again. And we talked about this before. Could I combine those steps?
Absolutely you can. And I'm going to go ahead and actually, they're doing some major construction in our building.
Sorry about that, guys.
All right. You guys will probably already be enjoying it by the time that you watch this video. So, yes, anytime that you notice, not wanting to get rid of my period, anytime that you notice that you're using the exact same reason for those two consecutive steps and one is not dependent on the other, then you can go ahead and put those two things together with the same reason.
And what if I notice it after the fact?
You can leave it as step 2 and step 3.
Okay.
We're not going to care either way.
Yeah, okay. Just wanted to clarify.
All right, now we have established these larger segments now, right?
Yes.
So we now have something with AC, we have something with BD, but we haven't really used the given yet.
And we kind of have to.
We have to use what they give us. It's there for a reason.
Okay.
So now we want to think about how can I talk about these things in terms of what I have. Do you notice anything here?
All right. Well, we haven't used the given, and all we did in step 2 was just write down the segment addition postulates. So
right.
We technically haven't used that either. So what I'm noticing is that since A, B, and CD are equal, like we could replace one with the other.
Sure.
And the reason why I'm thinking this is because if we're trying to show that AC and BD are actually equal to each other, and my step 2, right now they're not. Like if you look at it,
yeah.
AB plus BC is not the same thing as BC plus CD. You see that?
Yes.
And the only way I can make them set equal to each other is if those look exactly the same.
Right.
So let's say I'm gonna put CD in for AB.
Okay. So what would this equation look like if I substitute this in place of AB?
I would put CD plus BC is equal to AC.
Okay, and you said you use substitution.
Yes, because I replace CD with AB.
Okay, and you could say sub or subs, however you want to abbreviate that. Okay, now I see something else. Do you see it?
Okay, well, let me think. Okay, so I've used the given now, right?
Used the given.
And then I use part of step 2 because I substituted in that equation.
Right.
I still haven't used the other part of step 2, and now I have step 3. And I'm looking at it, and my goal is to make AC to equal BD in the end. That's what we're trying to get, right? We can't say they are in the beginning because we can't use the proof to prove it. So I'm looking at it, and I'm noticing AC and BD actually have the same exact measure because they equal the same sum. Now, does it matter if you put BC plus CD and CD plus BC? No.
Right, because they're equivalent.
Addition, you can do 5 plus 2 or 2 plus 5. So I can go ahead and say AC is equal to BD.
And what is that reason?
Well, one of my reasons I can think of is just substitute. I could substitute AC in for that sum in the one above it. So that could be work. Or I'm thinking maybe transitive as well because of the fact that AC and BD both equal the same thing.
Yeah, when they equal the exact same thing, they equal each other.
Now, does that mean anytime I use substitution, I can use transitive?
No, not every single time. We'll get more picky about when to use which later. For things like this, we could definitely use either one, but
Yes.
there are certain times you definitely can.
And you'll
only
notice
use
even in step 3,
one or the other.
transitive wouldn't have worked to get this new equation because all we did was replace one known value with the other.
Right. And yeah, notice I just put CD only in place of the AB. It wasn't that whole side of the equation.
Exactly.
Right.
All right, we're going to try one more. And this one, I will tell you, it has a similar kind of flow as the last one. And one thing you guys are going to notice is in the beginning with these geometric proofs, there's not a lot of differences in them. There's not a lot we can do. Right now, we can only deal with angles and segments because that's really all we've dealt with.
Right. And we haven't done very much with angles and segments yet. So once we get more things, we'll have more flexibility with our proofs.
Exactly. So we start our 2 column statements and reasons. Let's number our given So I'm going to write down my given. And notice, just like Mrs. Hochgravy on the last one, she labeled that. So I'm going to go ahead and right away, angle ABC's measure is the same as angle DBE's measure. And that's given to us. Now, again, take a look at where you were going. We're trying to prove that the measure of angle ABD, so this entire angle here, we're trying to show is equal to angle CBE's measure. So notice the two angles.
Oh, this looks a lot like the last one.
Except for this is dealing with angles. Notice the two angles that we're trying to show that are equal in measure kind of overlap each other. And that's kind of what we saw with the segments there.
Okay.
So we're starting with two smaller angles that are equal, and we're trying to show two bigger angles that are equal. So that's kind of our goal that we're trying to do.
Okay, well, and I also noticed that we're starting with measures are equal and we're ending with measures are equal. So
Good.
I definitely don't have to do anything with congruence in this one either.
Nice observation. Nice observation. All right, so first question is, based on that given, is there anything else that we can conclude just directly off of the given?
Other than that they're congruent, no.
Probably not going to help us. So
not going to help us.
So my next step is also, keep in mind where we're going. So if the given doesn't really tell us much besides, okay, we could say they're congruent, I always like to look at that picture and keep the given or the proof part in the back of my mind. So I know I want to show something about angle ABD. Right. And in that picture, the only thing we can say from the picture about that angle is what?
That angle, the measure of angle ABC plus the measure of angle CBD will equal the measure of angle ABD.
So just like Mrs. Hochgravy mentioned in the last one with the segments, we needed to establish something about angle ABD's measure. And the only thing we know is from that picture that those two adjacent angles add up to that larger one. And what's my reason?
Well, it's not segment addition postulate because these aren't segments. So angle addition postulate.
So AAP?
AAP.
Whoops, I almost put AR for some reason. I don't know why. All right, now we established this one. We got to establish this one and from the picture.
Okay. So now we can do another angle addition postulate, and I can keep it in step 2, right?
Okay, I'm good with that.
Okay, it's another statement, but same reason. So the measure of angle CBD plus the measure of angle DBE will equal the measure of angle CBE.
And she said same reason, that's why we could put it in the same step. They don't depend on each other. They're completely separate. They don't really have, I mean, they have something in common, as you can see in the statements, but they don't, one could have been before the other. That's how you know if it's dependent on it. All right, so we never used the given, it's just we wrote it.
Okay.
We haven't used step 2, we just wrote it. Just because you write it down doesn't mean you used it, so keep that in mind. And again, remember where we're going. So what are you thinking?
Okay, well, to start with my given, I knew that those two angles were equal measures. So I'm going to do just what you did on the last one. And I want to take the measure of angle DBE, and I want to put that in place of the ABC in that previous statement. Now, I could have also done the same thing with the angle ABC and put that in place of the DBE, right?
Yeah, because they're interchangeable.
Okay.
It doesn't matter. So she just picked that one, and that's fine. And again, you can do that because of the fact that these are equal. Now notice, Ms. Hochgravy did this too in the last one. I'm circling and drawing an arrow. This is more of a visual for some of you. You don't have to do that on your own, but I know it helps me a lot.
It helps me, and it's helped a lot of my students in the past too. And once you get more and more comfortable with it, you may not do it, but for right now, it's okay to show your kind of work. You could consider that over there.
Exactly. And just to backtrack, the whole point of us substituting, and this is where sometimes these can be tricky, the whole point of us substituting is we want to show that angle ABD's measure is the same as CBE. So right now, these two right here, if I look, they don't equal the same thing. And the only way we can make them set equal is if they do actually equal the same thing.
Right.
So we're going to try to make that look. And guys, some of you are probably looking at it and you're like, well, yeah, of course it is. We're not trying to trick you with that. We're trying to pick easier concepts and do that process there for you in a little bit easier way. Yeah. All right, so what do we do here?
That was substitution.
And you can do SUB. You can, Ms. Hochgravy also does it that way. Doesn't matter.
It doesn't matter.
All right. Now, what steps did we use? We already used step.
Okay, we used step 1. We used the first part of step 2. So now looking at those two, they're identical on the left-hand side. They're just different order, but addition order doesn't matter. So now I could go ahead and just put those two together to say that the measure of angle ABD is equal to the measure of angle CBE. And that reason, again, I could say transitive because they equal the same thing, they equal each other, or I could use some substitution and put that ABD in place of all of the measure of angle CBD plus the measure of angle DBE from step 2.
Yeah, you could take this, what she's saying, let me show a visual, and put it in here.
Yeah, either way, I typically call that transitive, but you could do either one on this one. Now, what if I had put the measure of angle CBE is equal to the measure of angle ABD? Because technically it's the exact same thing, but I'm just looking at what they asked me to prove, and this is the order that it asked me to do it in, so that's the order I did. But what if I had done the reverse order? Would that be okay to just leave it like that?
Technically, no.
Okay.
I know, and I know some of you are like, well, it's the same thing. But when you in your proof, it has to look exactly how you see it. So if you had, in step 4 written that, then your step 5 would have actually been
Is that symmetric?
Symmetric.
Okay.
So it would have taken you one more step. So in the end, it's not a big deal, but a lot of times that's why I keep saying take a look at what you're proving.
Okay.
So you know where you're going. One more thing is the 2 proofs that we've done, there are other ways of doing this. And some proofs, there's only going to be one way. Some proofs are going to have different ways. And that's something as we progress through this course, you're going to get more comfortable and you're going to know that that other way is acceptable.
Okay.